What is up, everybody? Welcome back to the weekly Wednesday live stream. And we are going through test number 3, the calculator section, which I'm stoked about. Last time we did the non-calculator section. And I'm still trying to tweak my setup here, so I'm getting more and more comfortable with this live stream software. It's really cool, this encoder. And now you can see me, I'm a little bit bigger. I was super small last time, so hopefully, and now I got the setup a little bit better. Let me know if the mic is hard for you to hear. I actually have another mic that I'm going to try out next week, but we're going to stick with the classic right now and go from there. So that's it. Thank you guys again so much for joining. For you guys taking the SAT coming up soon in the fall. Hopefully these are helpful or valuable for you. I've been getting a lot of really great feedback and comments from you guys watching. Can't wait to do it. Again, today's going to be under time conditions. We've got, I believe it's 38 questions in 55 minutes. So I'm going to be rolling through and explaining as I go along, but just remember, I have to do this within the 55 minutes to get through every question. So sometimes it'll seem a little bit rushed. And then we'll definitely review any questions if I do make a mistake. So without further ado, let's get started. So we're going to jump over here. And hopefully this all looks good as far as the setup. So what I'm going to do, actually, you know what? Just to be safe, I normally like to do that setup, but let me do it like this. So we're going to see here. This is going to be a little test. So do I fit nicely under there? I do. Okay, so that's the idea, is my screen is meant to fit underneath so it's not totally blocked and you can still see everything nice and clearly. Let me just shrink this a little bit more. Here we go. So I got it all queued up. Again, these are problems I'm seeing for the first time. It's part of the fun, and that's why I enjoy doing it. 38 questions, 55 minutes. Let me move my keyboard. Let me get all situated so I can go at optimum efficiency. All right. Ready, sit, and begin. All right. Oh, wait. Is this going to show up everything? Oh, boy. This isn't a great setup. I'm going to have to move this a little bit here because I can't read these problems completely. All right. That's better. All right. Perfect. The graph to the left shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. And what is this? Distance from her campsite. So she's going far away, and then she's coming back to her campsite here. She stopped for 30 minutes along the hike to have lunch. Which of the following is closest to the time she finished lunch and continue her hike? Where she stopped is where the distance isn't going to change. She's just in one spot for 30 minutes. It looks like it's this flat line here. Right here, she's kind of winding. She's going farther away, coming back, and then boom, lunch. Doesn't move, and then now again ventures farther away, and then comes back. So it looks like her lunch began at whatever this time is, and it's close to ending. Let's say this is 1:30 right in the middle, maybe 1:40, something like that. So I'm going to go with C and move on. The table to the left shows the distribution of age and gender for 25 people who entered a contest, right? 25 total. If the contest winner will be selected at random, what is the probability that the winner will be either a female under age 40 or male age 40 or older? So we want the probability that it will be female under 40, which is right here, so that's 8. Or it will be a male age 40 or older, male age, and there's only 2. So that means we've got an 8 and a 2. Now we want to know whether it's this or this. In that case, we just add these together and we say, hey, there's 10 people that can fit this category. And the probability is we have a total of 25 people. So the probability is just 10 out of the number we're trying to choose out of the total, which is 25. So I'm going to go with 10 out of 25. That can be reduced to, 2 out of 5, but they didn't reduce it. So that's okay. The graph to the left shows the number of music album sales in millions each year. Look how heavy this is on data analysis. It's crazy. Total number of music in millions each year from 1997 to 2009. So again, this is in millions, 600 million, 400 million, right? Based on the graph, which of the following best describes the general trend in music album sales from 97 to 2009? It looks like, right, this is 97, this is 2009. It looks like they're going down. Little spike here in 2001 and then a drop. So I'd say sales increased until 2000 because this is 3 plus 1997. This is 2000. Increase, that sounds good. And then generally decrease. I agree with that. It's the most specific because it includes this rise and the decrease. These miss those changes. So that's a good answer there. All right, function question. Here we go. Table shows some values of the linear function f. Which of the following defines f? All we got to do is say which one of these works for these values. So if we plug in 1, we get -2. That works for this. 2, we get 1. Nope, doesn't work. So I'll say A, B, C, D. We've disproved A. Now we'll go down the line. 2n minus 4. 2 minus 4, right, is -2, yes. 4 minus 4 is 0, not 1. B goes away. You see how I'm doing this? I'm just plugging them in. Fn 3n minus 5. So 3 times that 1 is 3, minus 5 is -2. 3 times 2 is 6, minus 5 is 1, yep. 3 times 3 is 9, minus 5 is 4, yes. 3 times 4 is 12, minus 5 is 7, yes. So C is our answer. I'm not even going to go through D because I want to make sure we finish everything. I'm sure D was wrong. Next, we go to Lincoln High School. Approximately 7% of enrolled juniors and 5% of enrolled seniors were inducted in the National Honor Society last year. 7% of juniors, 5% of seniors. If there were 562 juniors, right, and 602 seniors, which of the following is close to the total number of juniors and seniors that were inducted into the National Honor Society? I'm going to go straight to calculator. So they said 7% of this and 5% of this. So we're just going to do some multiplication. I got the calculator ready. 562 times 0.07 plus 602 times 0.05. Boom, 69. 69. We got a decimal, but that's okay. Approximately. So we got 69. We're good to go. Next question. Number 6. We got, ooh, nice. We got quadratics. I love these problems. So not a lot of reading. Which of the following is the sum of these polynomials? Let's just add them up. And let's add them up. Common term. 3x squared plus 5x squared, 8x squared. Okay. -5x, -2x, -7x. 2 and -6 is -4. You see how I did that? That's it. 8x squared minus 7x minus 4. Option A. Done. Move on. Question number 7. We're doing decent with time. We've let 5 minutes elapse. Solve for W? Straight up, we're going to we're just going to isolate. This is pretty basic. Let's multiply both sides by the reciprocal of 3/5, which is 5/3. And we got 5 times 4 is 20 over 9, which is D. Done. All right. The average number of students per classroom at Central High is 2000 to 2010 can be modeled by this equation where X represents the number of years since 2000, right? So 0 at 2000. Y represents average number of students per classroom. Which of the following best describes the meaning of 0.56? 0.56 is multiplying our X. It's clearly the change. It's the rate of change that the classes are either increasing or decreasing. In this case, it looks like they're increasing. So it's not the total. Anything multiplied to X is the slope, which is the rate of change. It's not that. We're not talking estimated increase in average number of students. It's this guy. Increase, change, slope. Estimated difference between the average number of students per class. No. So it's C, right? Understanding equations, big category. Need to be comfortable with that. Nate walks 25 meters in 13.7 seconds. If he walks at the same rate, which of the following is closest distance he'll walk in 4 minutes? So check it out. I can do it a couple different ways. I mean, really, we can divide 4 minutes by 13.7 times 25. So, I mean, I just say our rate goes 25 meters in 13.7 seconds. And we want to know how many does he go in 4 minutes. So, I mean, you can do like conversions here if you wanted to. You could be like, well, I'm going to convert this to, let's say, minutes, first of all. We could say minutes, seconds, and we do 60 over here. And then whatever we get, we would just multiply by, oh, wait, did I do this right? 25. This setup may be wrong, actually. Let me rewind. Let me just do it the way that I was originally going to show you. So we're going to divide 4 minutes, which is 240 seconds, by 13.7. 13.7. I'll relook at that if I have time as to why I botched that setup. But anyways, and then so that is how many seconds that's how many 13.7 goes into 4, and then multiply that by 25. And we get 437. 438 if we round up. And I'd say 450 is our answer, right? This looks right. It makes sense. In about a minute, he's walking about 100. Because the 4 times this is close, right? It's like 42, whatever. So it's more than 100. 450 sounds good. Let's move on. Actually, if I rethink about that one, 13.7, did I do everything? Yeah, I think I did that right. I'll revisit it. So anyways, the chart above shows approximations of the acceleration due to gravity in meters per second squared for the 8 planets of our solar system. The weight of an object on a given planet can be found by this, and where weight is the object measured newtons, blah, blah, blah. Okay, formulas, no worries. What is the weight in newtons of an object on Mercury with a mass of 90? So Mercury, and the weight is W equals mass times the gravity, which on Mercury is 3.6. And we said a mass of 90, so this is just straight multiplication. I can do this in my head, I think. 270 plus 54 is 324. All right, let's do the next one. Scroll down. An object on Earth has a weight of 150 newtons. Whoops, so it's the W. Which of the following would have the same... So 150. So we got to solve for the kilogram. So it's 9.8 times kilogram. We don't know what that is. 150 divided by 9.8 to solve. 150 divided by, it's about 15, right? So 15.3 kilograms is the object. And we want to know how much does it weigh on Mars. Wait, where would it? On which planet would it have 170? So now we make a new equation. 170 equals 15.3, that's the Newton, that's the mass, sorry, times the gravity. And we don't know, so we got to solve. 170 divided by 15.3, 170 divided by answer in this case, and we got 11.1. So it's a gravity of 11.1. Does anyone have a gravity of 11.1? Yeah, it's Saturn. So Saturn is our answer. Oops. Good. Next question. If the function f has 5 distinct zeros, which of the following could represent the complete graph of f? Means it crossed the x-axis 5 times. 1, 2, 3. Nope. 1, 2, 3, 4. Nope. 1, 2, 3, 4, 5, 6. Nope. Too many. It's probably D, but let's see. 1, 2, 3, 4, 5. Beautiful. D. That's all it's asking. If you know what it's asking in that question, it's super fast. This equation gives height of a ball, so it's quadratic function. Height of a ball in t seconds after it is thrown straight up with an initial speed of v feet per second from height. Okay, whatever. Which of the following gives v? And so all we're doing is we're isolating v. That's all this is asking. You look at all the answers. They're just isolating v. Once you know that, go for it. So I'm going to do it step by step. So first, let me write the whole thing. H equals negative 16t squared plus vt plus k minus k. I'm going to do it simultaneously in minus 16t squared. Goodbye. We got to do them from this side also. Minus 16t squared. So we got h minus k minus 16t squared equals vt. Divide both sides by t. Divide both sides by t. And this is your answer right here. So it's h minus k minus, what did they do? They broke it up. Okay, you can do that too if you want. So it looks like, I'm guessing this is going to be the answer, D, but let's actually do it. So they just basically split this up into 2 fractions, h minus k over t minus, which you could totally do, and it's totally allowed, right? Because we could recombine these if we wanted, and then they factored out, they crossed off the t's. That's how they got minus 16t. So, oh, wait a minute. How did we get a plus? Let me just double check. Oh, this is a negative 16. I didn't see that. So we're adding. So it's actually plus. So it's this guy. See, you made a mistake. If you're really attentive and you don't brush those little mistakes and those discrepancies under the rug, you can figure out an answer where you went wrong sometimes. The cost of using a telephone in a hotel meeting is 20 cents per minute. Which of the following equation represents the total cost in dollars for h hours of phone call use? So this is 0.2. Let's see, what are they doing here? They're doing 60h. Oh yeah, because you have to multiply the h by, it's a. You have to multiply the h by 60 to get the number of minutes, and then that times your 20 cents. So this is pretty simple. It's just this. This makes no sense. 60 times h makes sense. You don't divide though. You got to multiply in this, right? So those are just random variations that don't make any sense. In order to determine if treatment X is successful in improving eyesight, a study was conducted from a large population of people with poor eyesight. 300 selected at random. Okay, so they have 300 with poor eyesight. Yeah. And half of the participants were randomly assigned 150 got X, and the other 150 nothing. Then the resulting data showed that participants who received X had significantly improved as compared to those who did not. Based on the design and results of the study, which the finding is appropriate conclusion. Treatment X is likely to improve the eyesight of people who have poor eyesight. I'm feeling that's it. I have to think about this. Improves eyesight better than all of it? No, we don't know that. Treatment X will improve the eyesight? No. Treatment X will cause substantial improvement in eyesight. I think this is best because it says the sample is from... It's specifically from a population of poor eyesight. So we don't know if it'll improve eyesight with people in general. But with poor eyesight, it looks like that's a strong conclusion. Next question. I want to know if this setup is good, by the way, so let me know as far as how I've laid everything out. Graphs of the function f are shown in the xy plane to the left. For which of the following values does f plus g equal 0? Basically, they're just saying where if you can find a value at some point where the y value here and the y value here, if you add them together, you get 0. And it's definitely here at -2, right? This is positive 2, -2, it would be 0. So that's pretty straightforward. 0 wouldn't work. At -1, it wouldn't work. They're both negative. And at -3, it wouldn't work. They're both negative. So it's got to be 2. So again, this might be cut off right now so I'm going to try and see if I can get you to view this problem properly. The quantity of a product is supply and product supplied, and the quantity of product demanded, supply and demand, in an economic market are functions of the price of product, which is P. The functions are the estimated supply and demand functions. This is supply. Okay, whatever. We don't need to read the rest. How will the quantity of the product supplied to the market change if the price of the product increased by $10? So we want to know how is supply affected. So supply is affected if the price increases by $10, it'll go up by 5. Because you can tell if this goes up by 10, right? 10 times 1/2 is 5, and then that's going to change the supply. So it's going to quantity supplied will increase by 5. So this one down here, if you can't see it, let me see. I can't really scroll down. So what I can do here, let me move this over here just so you can see it for a second. At what price will the quantity of the product supplied to the market equal the quantity of the product demanded by the market? Now we got to set these two functions equal to each other. That's all it is. So it's 1/2 P plus 40 equals 220 minus P. Add P to both sides. That's 3.5 P. Subtract 40 from both sides equals 180. Multiply both sides by 2/3, which is the reciprocal. Right, this goes away. 2/3 of 180 is 120. So the price at 120. That's it. Next question, 19. So at the halfway point, and we got a solid 40 minutes left, but you can't be fooled by that because questions are going to start getting really hard. Graphene, which is used in the manufacturing of integrated circuits, is so thin that a sheet weighing at 1 ounce can cover 7 football fields. That's so cool. If a football, I bet you that's true. I just have a feeling that they usually use true information. If a football field has an area of 1 1/3 acres, how many acres could 48 ounces of graphene cover? So we can set up a cool ratio. So 1 ounce can cover 7 equals 48 ounces. You can cover X. So this will get the number of football fields. Then we take the number of football fields and multiply that by 1 1/3 acres, right? Because each football field is 1 1/3. So first let's cross multiply and solve this. 7 times 48, 280 plus 56, 336. You can use a calculator again. It's calculator section equals X. That's it. So 336 times 1 1/3. So what is 1/3 of this is 112. So we just basically add 112 to this. Again, use your calculator. Don't do it mentally like me if you don't have to. 448. So it says approximately. I'm going to 450. That looks good. Next. Here we go. Michael swam 2,000 yards on each of 18 days. The scatter plot to the left shows his swim time for and corresponding heart rate after each swim. Swim time and heart rate. So it looks like the longer the swims, sort of, heart rate goes down. The shorter swims in this zone, 34 minutes, his heart rate's higher for whatever reason. There's a line of best fit. For the swim that took 34 minutes, Michael's actual heart rate, not line of best fit, actual heart rate was about how many beats per minute less than predicted by the line of best fit. So his actual was here, which is 140, 142, 44, 46, 48. So his actual is 148, and the line of best fit is at 150. It's 2 less. That's it. Question 21. Of the following 4 types of savings account plans, which option would yield exponential growth of the money in the account? Okay, so wait, what? Each successive year, 2%, we want exponential growth. 2% of the initial savings is added to the value of each account. No. Because this won't change. Of the initial savings, it's taking 2% of something that's stagnant. So it's usually going to add, if you put in $100, you get $2 every year. That's not exponential. 1.5% of the initial savings and 100 is added to the value of the account. No, because it's, again, fine. It could be a nice extra 100, but you're still adding the same amount every year. Each successive year, 1% of the current value is added to the value. This is good because you're taking what's in the bank. So first you have 100, then you have 101, then you have 1% of 101, which is like 1 point something, right? So that value slowly growing. It's going to get bigger and bigger. This one is definitely linear. Just $100 is not exponential at all. The sum of 3 numbers is 855. X, Y, Z. They add them up to get 355. One of the numbers is X. One of the numbers X is 50% more. So if X is 50% more, meaning 1.5, then the sum of the other 2 numbers, then Y plus Z. X plus Y plus Z equals 855. What is the value of X? System of equations, not too bad. Let's isolate Y plus Z here, and we can plug it in. Y plus Z equals 855 minus X. Plug that in for this. We get X equals 1.5 times 855 minus X. 1.5 times 855. Let's see if I can do this in my head. Half of that is 4. It's going to be a decimal, shoot. So these are not... Wait a minute. This is not giving me a whole number. 50% more, right? So that's a little strange, but we'll roll with it anyways. So 50% more than the sum of those two. Anyways, so 855 minus X. So let's just do calculate. I don't want to be too crazy. 55 times 1.5 equals 1282. 1282.5 minus 1.5x. So we're going to add this to the other side, and then we get 2.5x. Oh, it'll be fine, actually. 1282.5. Divide both sides by 2.5. Divide by 2.5 equals 513. So x should equal 513 right there. Boom. That was a little tricky, but we got it. Angles shown to the left are acute. Sine of A equals cosine of B. If blah, 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 if A equals this, B equals this, what is the value of K? Interesting. Let me process this for a second. Sine of A. But if sine of A, the strange thing is, if these are in a triangle, if this is A and this is B, sine of A is opposite over adjacent. Cosine of B, they're the same. That means they're part of a triangle. That means of a right triangle. That means A plus B. I don't know if this is the best way to do it, but A plus B should equal 90. That means 4K minus 22 plus 6K minus 13 equals 90. 10K minus 35 equals 90. 10K equals 125. Divide by 10, K equals 12.5. And it's there. I think that's a good way to do it. There might be an easier way to do that as well, but I'm not going to mess with that right now. Okay, let's go ahead and knock this guy out. Mr. Cole has a beaker containing n millimeters of a solution to distribute to students in his chemistry class. Gives each student 3 millimeters. He will have 5 left over. Okay. In order to give each student 4 milliliters of solution, he will need an additional 21 milliliters. How many students are in his class? So he wants to give 4 out. I got to think about how to set up this equation. Could also guess and check, but I don't want to do that. So let's see. Something divided by 3 gives you a remainder of n. N divided by 3 gives you a remainder of 5, right? And then n plus 21 divided by 4 has no remainder. So I think I'm gonna have to plug in because I'm not totally sure I'm on it. So let's look at these. If n is 16, right? No, wait, we're solving for how many students are in the class. So first let me solve for n. It would be, let's see, I'm gonna try some different things here. 42, 15, 16. Well, which one's gonna give us a remainder of 5? Let's start there. So if he has 16 students, right? And if he has 16 students, so let's say 16 divided by 3 gives us a remainder of 1. 21 divided by 3, no remainder. 23 divided by 3 gives us a remainder of... Oh, no, we're not talking about remainders. Oh. Okay, it said he'll have 5 left. Whoa, all right, hold on. I've kind of messed this up a little bit. 3 milliliters solution have 5 minutes. So there's less. So he can give all of it away. Oh my gosh. I've wasted a lot of time on this question. I may have botched my timing up. Let's see. So he gives 3 left and he needs 20. Okay, so he needs 21 more milliliters. So let's say 4 milliliters. So n divided by... Okay, hold on. He's got 16 students, and everyone gets 3, so that's 48. So let's assume everyone gets 3 is 40, and that's 53. And then if he's got 4, this is for 16. If he's got 4, that's 48. 4, that's 64. 64, and he'd need, no, that's, so 16's not right. I'm doing process of elimination now. It's what it is. So 3, he gets 60, he hands out 63, and he has 5 left, so he has 68 total. And then he gives 4 is 84, and he would, 23. He gives 3 at 69, and to give out 4, he'd need 492. And 69, and that means he has 92, and he has 74, and he'd need an additional 18. 26 is 3, everybody would get 60, 78, and then he'd have an additional 5, so that's 83. And then to give 4 times 80 plus 24 is 104. Yeah, it's this one. All right, so then he'd need 21 more. That's a really terrible way to solve a problem, but I just couldn't think of the way to do it. All right, let's move on. We got to hustle. It's 29 minutes left. A grain silo is built from 2 right circular cones, and right, so we got the cones, and a cylinder with internal measurements to the figure left. Of the following, which is the closest to the volume of the grain in cubic feet? What is it? Which is the following is close to the volume of the grain? Oh, so it's all these different pieces. So let's do it. We got the cylinder part. It's just pi r squared times height, which is 10, and the radius is 5, so it's 25, so it's 250 pi, right? That's this guy. And then these cones, it's pi r squared, which is 25 pi times height, which is 5 times 1/3. But we got 2, so I'm going to do it all at once. So 1/3, that's a 5/3, 10/3 times 25 pi. So let's just add, so we're adding these two. So 250 pi, and this is also 250 thirds. 250 over 3 times pi. So 250 pi, 250 pi plus 250 pi divided by 3, 1047.2. Boom. Next question. 26. In the xy plane, the line determined by this and this passed through the origin. Cool. Whoosh, whatever it is. Which of the following could be the value of k? All right, so we need to know that this passes through the origin. meaning it has no y-intercept. Y-intercept is 0. So we can do, I'm going to play this by doing a little point slope here. So let's try it like this. Y equals, let's see. So the slope we don't care so much about. So it's like, actually, yeah, let's try it like this. Y minus, let's say k equals m times x minus 2. Actually, let's do the slope. 32 minus k over k minus 2. So this is the slope. So we need a slope now. So then it'd be like y minus, let's add it up over on the other side. So slope is 32 minus k over k minus 2, right? Times x, which we again don't really care. But this distributes here, minus 2 times, it might be an easier way to do this. I'm just thinking, let me expand this a little bit. 32 minus k over k minus 2 and then plus k. So it's this value has to go to 0. So negative 2 times 32 minus k over k minus 2 plus k equals 0. Let's make some room. So we got let's just distribute this. Negative 64 plus 2k over k minus 2 equals negative k. Multiply both sides. Negative 64 plus 2k equals negative k squared plus 2k. Let's make more room down here. So this is going to be a quadratic function. Could have plugged in, I suppose, too, but I think this is better. Since k squared, I'm moving to this side now. We get a positive k squared. K squared, the 2k's cancel out. K squared minus 64, it's a difference of squares. K plus 8, k minus 8. So it's either 8, negative 8. 8. 2 solutions. Yikes, that was pretty hard. How are we doing time-wise? Not bad. I think we're going to be okay. 12 questions left. A rectangle was altered by increasing its length. So say xy. By increasing its length by 10%, meaning it's times 1.1, and decreasing its width by p%. Okay, so it's decreasing by 10%. So let's say it's decreasing by 10%. That means you're actually multiplying it by 100 or something minus. No, sorry. If we're decreasing by 10, 100 minus p. That's the way to think about it. Because you're decreasing by 10%, it's going to be 90% of what it originally was. And this would actually be over 100, right? If these alterations decrease the area of the rectangle by 12%, what is the value of p? So let's think about it in terms, I'm just going to keep this as a decimal. So 1.1 times, and then it's basically 1 minus p. 1 minus p equals 1.1 times 1 minus p equals, so it's increased by 12%, so it becomes 1.12, right? So 1.1, let's see, what is the value of p? And I think this should give us our answer. So it's 1.1 minus 1.1 p equals 1.12. Subtract both sides by 1.1, and we get negative. Are we going to get a negative number here? What? Oh, because it's a decrease. Negative 1.1 p equals 0.02. 0.02 divided by negative 1.1. 0.02 divided by 1.1 equals, and that's 1.8%. But that doesn't look like what they had. What is the value of p? Something has gone awry here. So let's reset and let's try and tackle this one more time. So it's increasing its length by 10%. Here, let's do it like this. Increasing the length by 10%, which is what we did here. Decreasing this by p%. You know what? I'm just gonna leave p in, and I'll know that we'll know how to manipulate it. So the area is x, like p times 1.1, right? xy equals 1.12. And decrease the area. That's why. Decrease it by 12%. So it's actually 0.88. The xy's go away anyways. So it's just 0.88 divided by 1.1. Equals 80%, which means it was a decrease of 20%. All right. Yowzas. In planning maintenance for a city's infrastructure, a civil engineer. So we're in bad place with the time right now. 22 minutes for 11 questions is not great because they're going to be hard. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease 10% every 20 years. 20 years. If the present population of the city is 50,000, which the following exponents represents the engineer's estimate of the population t years from now. So it decreases by 10%. It's going to be something with 0.9. A and B are gone. This is wrong. And every 20 years, so this would be at 20, it would be 1. So it's dropping by 10%. At 40, it'd be it's D. This one would be crazy because every 1, 2, 3, it's going bananas here. This is what we want. Okay, I don't have time to explain super in depth right now. I got to get through this. So the incomplete table to the left summarizes the number of left-handed students and right-handed students. Left, right, total. Cool. There are 5 times. Let's redraw this. F, M, T, L, R. And there's 18, 122 in the total. Cool. Like this, right? And it says there are 5 times as many right-handed female students. So there's 5 times as many right-handed female students as there are left-handed female students. So if we put X here, there's 5 times as many right-handed. Okay? So 5 times as many right-handed female students as there are left-handed female students. And there are 9 times as many right-handed male students as there are left-handed male students. Okay? If there's a total of 18 left-handed students, right? And 120 right-handed students, which finds the probability that a right-handed student selected at random is female. Right-handed student selected at random is a female. So we got 122. So I think I have to solve for this. It's like female is 6x. Okay. So x plus y equals 18. 5x plus 9y equals 122. Yeah, it's a system of equations. -5. So it's -5x minus 5y equals -90. Goodbye. This is 4y equals 32. Y equals 8. So y equals 8. X equals 10. All right. So what is so which of the following is closest probability that a right-handed student selected at random is female? So we break it down to 122. And the female right-handed are 5 times x, which is 50. So 50 over 122. 50 is 0.4. 0.409. 0.410. Good. 3x plus b equals 5x minus 7. 3y plus... Okay, and the equations about b and c are constants. B is c minus 1/2. So the following is true. 3x plus c minus 1/2 equals 5x minus 7. 3y plus c plus c equals 5y minus 7. And then, so what are we trying to do? X is y minus... So we want to get x into... so we're just trying to solve for x in terms of y. And... this one, can we get an equation? We have to plug in, I get it. Isolate c here. So this is c equals 2x I'm doing this fast, okay? Minus 6.5. I threw everything over, subtracted 3x, added 1/2, so it's this. And then I'm going to plug this in here. So let's move this down a little bit. So we've got 3y plus 2x minus 6.5 equals 5y minus 7. So that means we got 2y. We're trying to isolate x here, I see it. 2y minus 7 is 2x minus 6.5. So we add 6.5, 2x equals 2y minus 1/2. We divide both sides by 2, and we get x equals y minus 1/4. So x is y minus 1/4. There we go. This is hard. These are hard problems. Tickets for a school talent show cost $2 for students and $3. Oh, free answer. This will be easy. Yes. So we'll speed up a little bit now. $3 for adults. If Chris spends at least $11 but no more than 14 on X student tickets and 1 adult ticket, so he's already spent $3 for the adult and he's got whatever amount left. What is one possible value of X? Well, I'm going to buy 4. How about? Let's just make it 5. So 5, and then we get 10 and 13, so you can buy 5. This table to the left lists ages of the first 12 United States presidents when they began their terms. According to the table, what was the mean age in years of these presidents at the beginning of their terms? So this is beginning their terms. So what was the mean? All right, yeah. So we got to add all this up. So I'm going to write it down here. This will take a little longer. If I had a calculator handy and not on the screen, it'd be faster, but it's okay. 59 plus 58. I got to be really careful because it's free response, so I can't make mistakes. 68, 51, 50, 65. Okay, hopefully I got them all right. Let's do it. 57 plus 62 plus 58 plus 58. 59 plus 58 plus 62 plus 55 plus 68 plus 51 plus 50 plus 65 equals, divided by 12, right, is 58.5, 58.6. We'll come back and check. I did this really fast, so I could have made a mistake, but I'll come back and look at it if I have time. Next. What is the expression above written? Ax plus b, blah, blah, blah. What's the value b? That's it. Just combine these guys. Negative 3x squared plus 5x minus 2 minus 2. I'm distributing the negative 2x plus 4x plus 2. So this and this becomes negative 5x squared. We don't care about that. We care about the middle term only. It's 9x, 9. You see, I mean, I have to go fast to make up for those other questions where I was really stalling. Give a good chance of doing a good job here. In a circle with center O, terrible. Center O. The central angle AOB, right? AOB has a measure of 5 pi fourths radians. The area of the sector formed by the central angle is what fraction of the circle? This is just 5 pi over 4. And the whole circle, you go all the way around. In radians, 360 is equivalent to 2 pi. We just do this division problem. I like to write division fractions like this. It's a little strange, but we got, 5 pi over 8 pi. Pi is canceled out. It's 5/8. So is what fraction? So we just do a fraction, I think, like this. Let me see if that makes sense. Yeah, that makes sense because pi is 180. 5 pi is a little more than 180. Good. There we go. An online store receives customer satisfaction between 0 and 100. The first 10 ratings that the store received, average of the ratings was 75. For the first 10, whatever, is 75. What is the least value that the store can achieve? So this is 750. What is the least value the store can achieve? The store can receive, for the 11th rating and still be able to have an average of 85 for the first 20 ratings. What? 11th, wait, hold on. What is the least value the store can receive for the 11th and still be able to have an average of at least 85 for the first? Oh, I see. Okay. So 85 times, so we need to get 170. So we need to have a total of 1,700. And we're already at 750. And then the last, so then 12 through 20, which is 9. So we need to be able, so not, let's say we max out 9 at 100. So we get 900 plus 750, which is 1650. So that means that 11th can be 50. So this is assuming we get 100 on everything else. And we've already gotten 75. We can get 150, and then we can ace everything else, and then we'll end up with a total of 1,700. And you average 1,700 becomes 85. So I'm going to go with 50. That's a really, really tough mean question. Let's go on to the next one here. Y is less than or equal to negative. So we got 12 minutes. We're doing okay, actually. We made up some time. System of inequalities. In the xy plane, points A, B lies in the solution set of the system of inequalities. What's the maximum possible value of B? I'm just going to kind of think about this because here we got 3,000. I'm going to sort of graph it out. 3,000, we got a slope of negative 15x, right? Kind of like this. And then y is, it's less than, so it's all below it here, right? Let's just do a little shading. And then we've got y is less than or equal to 5x. So 5x goes through the origin, and it's got a positive slope of 5. Not exactly like that, but, and it's going to be everything less than this as well. So something like this. Oops. Now, where we care about the solution set is the overlap. So you see the part where I've got red and blue. So it's basically going to be, I'll just make it green. It's this area. And the maximum value is going to occur right here at this intersection. What is the maximum value of B? And since it's less than or equal to, it's on that line. So we just got to find the intersection of these two guys. And what does it want? It wants the Y value. So let's set these guys equal to each other, and then we'll solve for Y. So it's negative 15x plus 3,000 equals 5x. So we'll add 15x to both sides. 20x equals 3,000. Divide both sides by 20. X equals, I believe it's 150. Because 3,000 divided by 2 is 1,500. Divided by 20 should be 150. Plug this into either equation. 5 times 150 is 750. So that's the max value. And if I plugged it in here, we should get the same thing. So like 15, let's try it. 15 times negative 150 times 150. And then it's like 3,000 minus 250, and you get 750. So we know we're good. We checked in both equations. And then we got a pair of questions again. So let's see if you can read this, hopefully. If shoppers enter, those are the last two questions. So we did well. We got 10 minutes left to do these two questions. Great. If shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time of T minutes. The average, so that's rate. Average number of shoppers in the store is this. So just as an equation. A lot of that stuff you don't even need to read. This relationship is known as Little's Law. The owner of the good deal store estimates during business hours 3 shoppers per minute enter the store. So R equals 3, he's saying. And then each of them stay 15 minutes. T equals 15. Store owners use Little's Law to estimate that there are 45 shoppers in the store at any time. Cool. All right, 3 times 15, that's it. Little's Law can be applied to any part of the store, such as a particular department checkout line. Store owner determines that during business hours, 84 shoppers per hour make a purchase. So 84 shoppers per hour make a purchase. And each of these shoppers spends an average of 5 minutes in the checkout line. So at any time during business hours, how many shoppers on average are waiting in the checkout line to make a purchase at the good deal? So he's got, let's see, 84 shoppers per hour, and each one, so we're saying 5 minutes. I see. So we got 84 in there. About how many shots? So it's spread out, right? So they've got these. So we can split. I'd say split this into 12ths. We would divide this by 12 because, and that actually is 7. It should be 7. Okay, the reason why I'm doing that is because if we take an hour and we split it up into 5 minutes, okay, we would do that 12 times. 12 times 5 is 60, right? Dot, dot, dot. And so now we basically realize we got 12 slots, and we got 84 that are in there. We just divide them up into 12. So we got 7 here, 7 here, 7, right? And then those will all add up to 84. So this is an average, like this is an estimate. You could have all 84 theoretically in line at once, but this is a good estimation. I think this is what they're asking. The owner of the goods deal store opens a new store across town. The new store, the owner estimates that during business hours, an average of 90 shoppers per hour, 90 per hour, enter the store, and each of them stays 12 minutes. Cool. So they entered the average number of, I'm going to go back to that just to make sure as well. I didn't exactly use the formula. I don't think you needed to though, but so we've got, so anyways, the average number of shoppers in the new store at any time, average number of shoppers in the new store, so n equals 90 times 12. Average number of shoppers in the new store at any time, oh wait, 3 shoppers per minute. So these are in different, so it's actually 90 over 60 because that's per hour. Is what percent less than the average number of shoppers in the original store at any time? So the other one was 45, right? We got this answer here. So it's 90 over 60, which is 9 through, which is 3 over 2 times 12. And 3 halves of 12 is 18, right? I can do that in my head. And the answer is 4. Okay, so we just put no percentage. So this is a crazy question. Now they want to know what percentage less. So basically, this is, they want to know what percent. So that's 27 less. So we want to know this percentage. And I believe if we divide both by 9, we get 3/5. So it's 60% less. Okay. There's a lot, we have 6 minutes left, so there's a lot that we can review to make sure that we've done these questions correctly. So I'm going to do that. I'm going to go through and I'm going to make sure that some of these questions we've done correctly. Let's first look at 37 and 38, and then we'll flip back. So little's all can be applied to any part of the store. So we got 84 shoppers per hour make a purchase. And then average of 5. So, I mean, I feel like we don't need this. It's 84 over 60 minutes. It's like 84. I mean, no, I don't think that makes any sense to, for average of t minutes, 5 minutes. So I'm just trying to process to see if that made sense to you, if it would have made sense, because if we would have done it, I don't think we do 84 over 60 times 5, right? And this one is 84 over 60 times 5 equals 7. Oh, we get the same answer. I didn't use the formula, but I get, okay, so that makes me feel good. I'm pretty good with this as well. We used the formula, we plugged it in, we got 45. As long as I'm understanding that percentage question, the average number of shoppers in the store at any time is what percent less than the average number of shoppers in the original store at any time. So I believe it's 60% less. So 60%, it's 40% of it, so it's 60% less. So I think we're good there. All right, let's go backwards now. Oops, hold on, let's see if this works. This I'm good with. I feel like we're good here. That one was pretty good. This one was fine. This one I want to add up one more time. So let's see. Let's see if I can do this the right way here. Let's move this over here so I can see everything very carefully. So we'll say, all right, and I'm going to use the keyboard. So we got 57 plus 62 plus 58 plus 58 plus 59 plus 58, 62 plus 55, 68 plus 50 plus 65 equals divided by 12 equals 58.6. Okay, I'm good with that then. And let's get this back into this guy. This one we're good for sure. I felt pretty good about this. I don't really have time to redo this problem, so I'm going to leave it as it is. This one I felt pretty confident too. That one definitely was right. Yeah, I think that one was good. The way we can check this, to be honest, is just do a quick graph. I mean, just quickly like think about this. So the coordinates are, if k is 8, then it's 2, 8, and then it's 8, 32. And we can just use point slope. The slope of this would be 32 minus 8, which is 24 over 6, which is, so it's a slope of 4. And then we use point slope, so it's like y minus 8 equals 4 times x minus 2. Y minus 8 equals 4x minus 8. Add it. Yeah, so it ends up having a y-intercept of 0, which is what we want. That means it's going through the origin, so we're good. 2 minutes left. This one, I'm pretty sure was perfect. This one was a little crazy, so let's check it again. And we got 57 seconds, yikes. So we said he's got 26 students in his class because he's got n milliliters of solution. And we estimated, what was it again? So 3 milliliters and he has 5 left. So 3 is 60, 78 plus 5 is 83. So we estimate he's got 83 milliliters. And then now he's trying to give all these guys 4. So that's 80 plus 24 is 104. And yeah, and he needs another 21. That's good. I'm going to go ahead and submit because oh yeah, let's just do it. Okay, let's see what we got. There's some of these that I definitely want to let's go just I think review this section. Hey, look at that. All right, so we got all of these correct. That's pretty cool. There's just that one. I want to see how they set it up, how they wanted us to set up anyways, the one that I just looked at. Let's see the milliliters. No. This one was good. Not this one. No, we were good there. Where's that milliliters one? Oh, I think I passed it. Oh no. Review. I should remember what number that was. Let's see. No. 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 Okay, I keep doing that. Last time, promise. Okay, so it's a multiple choice question. I'm obviously passing it. And the answer was 26. This one, here we go. All right, I just want to see what their explanation was. They said CV, the number of students in class. The conditions described in the equation are n equals 3c plus 5. Oh, yeah. Duh, totally could have set it up as a system of equations. Would have been so much easier. I just couldn't think of it at the time when I was trying to solve the problem, and that happens sometimes. And the lesson there is I couldn't think of a way to do it the standard mathematical way, which I usually always love to do, but because I couldn't think of it, I found a workaround, and I did plug in numbers at the end of the day, more or less. It's never my preferred suggestion because the goal is, right, when you're actually studying, you should try and learn the math. That's the whole point. And you can go so much faster. And I know all the math, and I mean, you can see, even as I'm explaining the problems and I'm talking about them, I still have enough time to finish the problems because I know it pretty well. But in a pinch, if you do get confused or you just can't fit it together in your mind, fine, plug in the numbers. But as a last resource, so there's the technique. That's it for the test today, guys. I hope that was helpful, and I hope this new format was good. I want to hear your feedback and thoughts as far as what you think about the layout, and I'm always a big fan of talking head videos. And studies show they're way more impactful and way more engaging, so it's a better learning tool for you guys. Thank you so much for joining, and let me know if you have any questions or if there's things that you want to see me solve. In particular, you want to send me some really hard SAT problems, do it, and I will solve it and give you a shout out. Make sure to subscribe if you haven't subscribed yet. We're going to have lots more great content coming to you this year, especially as you prepare for these tests and standardized tests in the math sections. New products will be coming out. Thank you guys so much. If you want to check out our website, of course, go to scalarlearning.com. So like, subscribe, and I'll see you guys next time. Take it easy.